Yo, what's up, math champs? If you've mastered solving equations with one variable, it's time to level up. Today, we're solving systems of equations using two methods, substitution and elimination. Let's break it down step by step. No stress, just success. So what's a system of equations? It's just two equations with two variables. The solution is the point where these two lines intersect. In other words, the values of x and y that make both equations true. Let's start with substitution. We'll use these two equations. Right here we have y equals 2x plus 1 and y equals negative x plus 4. Since both are already solved for y, we can substitute one into the other like this. Equals negative x plus 4. Next, we have to add x to both sides. So plus x. That will bring us to 3x plus 1 is equal. So what's a system of equations? It's just two equations with two variables. The solution is the point where these two lines intersect. In other words, the values of x and y that make both equations true. Let's start off with substitution, and we'll use these two equations. The first equation is y equals 2x plus 1, and y equals negative x plus 4. Since both are already solved for y, we can substitute one into the other like this. 2x plus 1 is equal to negative x plus 4. Our first step is to add x on both sides, so plus x. This will bring us to 3x plus 1 is equal to 4. Next, we know we must balance on both sides, so we must subtract 1 on both sides. This will bring us to 3x equals 3. Now, to get x by itself, we have to divide by 3 on both sides. Divide by 3. This brings us to x equals 1. If you plug that back into y equals 2x, putting the x in there, plus 1, you'll get that y equals 2 plus 1 and y equals 3. So the final answer, which will be in the form of x, y in parentheses, will be 1, 3. That's our final answer. Now, let's check out elimination. Great when both equations are in standard form. Our first equation right here is 2x plus y is equal to 7. And our second equation is 3x minus y is equal to 3. Our step 1 is to add the two equations, and look what happens. So here, if we add 2x plus y equals 7 equals 3x minus y equals 3, then we will get 5x, because you add 2x plus 3x. You add the y's, which cancel out because one is positive y and one is negative y. So that will equal out to 0. And then 7 plus 3 is equal to 10. So 5x plus 0 is equal to 10. If you subtract the 5 on both sides, we will get x plus 0 is equal to 2. If you subtract 0 on both sides, we both know that's not going to change anything. That will get us x is equal to 2. Now, our next step is to plug x equals 2 into one of the original equations. So if we have the equation 2x plus y is equal to 7, we will substitute 2 for x plus y is equal to 7. 2 times 2 is 4 plus y is equal to 7. And to isolate y by itself, we must subtract the 4 on both sides, which will leave us with y is equal to 3. So our final answer in parentheses format will be 2, which was the x, and 3, which was the y. This is the line which both equations intersect. Good job. Next, we have a practice problem. I want you to practice using both methods to get your answer, both elimination and substitution. I'll give you a second to figure it out. Okay, step 1. We're going to add the equations. So right here, we have 4x plus 3y is equal to 24, and 2x minus 3y is equal to 6. If we add both these equations, we will get 6x. This is going to cancel out plus 0. So which we're going plus 0 equals 24 plus 6 equals 30. Now we solve for x. 6x, we're going to negate the 0, equals 30. Which brings us to divide by 6, divide by 6. X is equal to 5. Now, we're going to plug that 5 into one of the original equations. So we're going to choose 4x. We're going to substitute the x for 5 plus 3y is equal to 24. 4 times 5 is equal to 20 plus 3y is equal to 24. To isolate the 3y, we have to subtract 20 from both sides. Minus 20, which leaves us with 3y is equal to 4. Now, to isolate y, we must subtract by 3 on both sides. So y equals 4 over 3. You could leave it as 4 over 3, or if you got a calculator or you want to do it the hard way, that is equal to 1.33. So the solution where the lines intersect would be 5, 4 over 3. Now, we're going to use this same question, but with substitution. So here we have 2x minus 3y equals 6. We're going to add 3y to both sides, which will leave us with 2x equals 6 plus 3y. Divide both sides by 2. Divide by 2. Divide by 2, which leaves us with x is equal to 6 plus 3y divided by 2. Now we're going to plug that into the first equation. So we have right here 4x plus 3y is equal to 24. We're going to substitute 4 bracket 6 plus 3y divided by 2 plus 3y is equal to 24. Now we're going to multiply 4 times 6 plus 3y. Make sure to close out the parentheses. Divided by 2 is equal to 24. Uh-oh, my fault. Let's get rid of this right here. This parentheses. 24 plus 12y divided by 2 right here is equal to 12 plus 6y. Now let's continue. 12 plus 6y plus 3y is equal to 24. So if we add these likewise terms right here, 12 plus 9y is equal to 24. You know we have to subtract the 12 on both sides to isolate the variable. So here we have 9y is equal to 12. Divide by 9, divide by 9. So y equals 12 over 9. If you see 12 and 9, they have similar factors. So that similar factor would be 3. So if we divide both of these by 3, it will get us to a simpler term, which would be 4 over 3, like we got in the last problem. So our last and final step in step 3 is we're going to insert that into the other equation. So we're going to go x is equal to 6 plus 3 times 4 over 3, and divide that by 2, which will give us x is equal to 6 plus 4 divided by 2 equals 10 divided by 2 is equal to 5. And that will give us the same solution as we got in the elimination, which is x right here is our 5. So right here we have 5 as our x and 4 over 3 is our y, just like we got in the other problem. For further notice, it's completely up to you on which method you want to use. Both work very well and very successfully if you do them all the correct way. If you have any final tips I would give you, would be to use elimination when variables are already lined up and easy to cancel, and use substitution when one variable is already isolated or easy to isolate. Good job, and I can't wait to see you guys next time.